Hey guys, welcome to Respiratory 3260 lab videos. This video is going to be about the high frequency oscillatory ventilator. This ventilator is commonly used in the neonatal pediatric population. I have seen it used on the adult side, but most commonly you'll see it in the newborn ICU setting. This beginning video is just to kind of show you the parts, the pieces, where everything goes, where everything is, and explain some of the theory behind it. There will be a longer video about theory, but for right now, we're just going to talk nuts and bolts. Let me apologize ahead of time. My headphones broke, and so I'm just using my running wired headphones, so we're going to go on some field trips today. Sorry. So let's start at the back of the ventilator. This is what the back of the high-frequency oscillatory ventilator looks like. So just as with any type of mechanical ventilation, we have 50 psi of air and oxygen that we have connected to the wall, and then electrical, which is connected to a red outlet. Okay, from our air and oxygen, it is connected to a blender. So the blender is how we adjust the FiO2 percentage we are administering to our patient. And that can go anywhere from 21 to 100% FiO2 and is just our chemical admixture. From that, it goes into our oscillator. This tube here is the outlet to the humidifier. As you can see, there's this big tube that comes down to our heater. So from our heater, and this one we have a Concha style of humidifier and heater. We can run this on a Fisher & Paykel. We have found you do get a little more rain out with Fisher Paykel, and the Concha is a little nicer, but you can do it with both, with whatever you have available or your facility has. As you can see, we have an oxygen analyzer in line on the dry side of the heater to come up so we can analyze the FiO2 with our oxygen analyzer attached. Okay, so from our Concha heater, we have our heater wires. They're kind of a little bit different, but similar theories. So we have the one closest to the heater. It comes up and enters into our piston. So literally, the high frequency oscillatory ventilator delivers both the active inhalation and active exhalation with a piston. We've made it fancier, a little bit nicer, but it used to be just basically old machinery. This on the back will be our piston. We have the rubber circuit and then this hard plastic. You will clamp that in with these dials that turn and make sure it is centered and secured. From that, we have drainage for additional condensation that can come into here, and then you can use a luer lock syringe or to drain any excess condensation that might come down. Out from there, we have our main circuit, which when it is on a newborn, you want as straight as possible. You want it as straight so that you can provide appropriate laminar flow instead of turbulent flow to that patient. Up here is our Y with a little plastic stopper. That is so you can test your pressures before you put it on your newborn, on your patient. So we always just keep that nearby, tape it. It's frequently you'll see it taped on top of the vent. Down to our Y. So we'll move, now that we moved out from the circuit, we'll move back. This port right here will stay closed, but it can be removed. And if you need to administer inhaled nitric oxide, that is where you will put your line, your analyzing line. And then we have our inspiratory and expiratory pressures we're administering, we're administering for our patient. So moving back, we have these kind of weird looking mushroom things What this does is it helps us direct measure what pressures we are giving. Okay? As you can see, we have the heated wire in the circuit, and you can follow these back, heater, and see there's 3 of them. There's a red, a green, and a blue. Sometimes these little diaphragms, they'll clip on and off, and you can change the little additional diaphragm in there so that if there is a faulty reason or they get broken, whatever reason, that they can change or they can be changed out or adjusted. Same with if excessive condensation gets in these pressure lines. So if you follow it back, you can see what each one controls. So the green helps us control our pressure, comes out and attaches, it does a little twist. It's a little bit like putting a bomb together. The dump, which comes out to here and to the end. Essentially think of that as your pop-off, your pressure pop-off. Similar to on the Draeger when you're doing conventional, your Pmax, anything like that. This is what controls, okay, our pressures are getting higher than our limit, which I'll show you the limit. And so that's where that pressure limit will dump the breath or those pressures. Airway pressure. So again, this is just a direct measurement. This is how we get feedback. So similar to that proximal gauge line on a V60, this is where airway pressure is measured. And then finally, the limit. This is to let us know when get that direct feedback of pressure for the limit we have set on our oscillator. So that's the circuit. It's a little intimidating at first, but once you break it down, it's really a lovely piece of equipment. So that's the circuit. It can be a little stiff. It gets better once it's warmed up, but it can take 2 people sometimes to move it around. A few other features before we go up to the main section I want you guys to notice is the power button. You gotta know how to turn on your vent. And then the piston that we center the ventilator. So one thing with the piston is it can get out of whack and it can kind of change how we administer ventilation. We want to make sure it's centered so that we're giving accurate pressures and so that the vent can work appropriately. With that, we're going to come up here to the main screen. So let's start up here. This is your mean airway pressure right here. All of these are direct measurements in centimeters of water pressure. So you don't want to try to make sure that your mean and your amps are not measuring the same, or else you're just basically giving oscillatory CPAP, and that's fun. So mean airway pressure is the average pressure you are holding those lungs open. And again, I'll go into depth on this a little bit more with the video on theory. Essentially, we use this for alveolar recruitment and oxygenation. So the 2 parts of oxygenation that you can adjust with the oscillator is mean airway pressure and FiO2. So then comes the next question. So here's my mean airway pressure, where it's going to be red. How do I adjust it? There are 2 ways you can adjust your mean airway pressure on here. So there is your bias flow. You typically will, I have it set at 20 right now because I'm going to calibrate it, but you'll typically want this somewhere between maybe 13 to 20. You have your limit. Remember the blue limit down here? The blue limit, and that's basically to help with the dump, make sure that we're not getting close to those pressures that we're trying to limit to prevent any continuous barotrauma. And then down here is how we adjust our mean airway pressure with our bias flow. So the mean airway pressure it works with this adjust bias flow green knob and our bias flow over here. So that is mean airway pressure, and I'll show you guys how we adjust that. This dial right here shows where your piston is as to center. So if you have your piston over here, you need to make sure you center it to make sure you're giving appropriate ventilation. We'll just finish off over here. These are your alarms so that you can adjust know when your pressures. So I like those somewhere between about 5 above and 5 below my mean. You'll set it in relation to your mean airway pressure. The most important button, silence. Reset power failure. Think of this as your pressurized button. So if for some reason your vent gets disconnected or you lose pressure for some reason, you can hold this and it will build up the pressures in your ventilator so that it can run appropriately. And then start and stop. You can start and stop your ventilator so that it will stop the oscillation but maintain that mean airway pressure so that we don't collapse down, but we can stop that oscillation in order to maybe listen to heart tones or do a certain type of assessment, see if how the baby's breathing on their own, anything like that. So we'll do start and stop, maintains mean airway pressure, stops oscillation. Inspiratory time. This is normally set at 33%. That will give us a 1:2 IE ratio. 99.5% of the time you won't see it changed at the 33%. So amplitude, this is your delta P, your change in pressure, from your mean airway pressure, again measured in centimeters of water pressure. And you will change this by changing the power. So as much as we want to use concepts we're familiar with and associate with, you have to think of back in 8th grade science class when we talk about sound. So amplitude, again, I'll talk about this a little more in theory, but you will use power to adjust your amplitude. So you do that by this little knob. If it's down, it's locked, which is really nice. So if somebody's like cleaning it or wiping the vent off for you, it won't get adjusted. To flip it up, you unlock it. And then you just turn it right for higher pressures, left for lower. Left, lower pressures. So when you're charting, you'll say, like, for example, let's go down to a normal. You could say like 2.8. See, because we have 2 in that little window and then 8 out on the dial. So you could say my power is 2.8 in order to give me an amplitude of 26 or whatever you're set at. And then just lock it when you're done so that it doesn't get twisted. Finally, hertz down here. We normally start at about 10 hertz. So 1 hertz is 60 cycles or 60 breaths. So if we are on a hertz of 10, that'd be 60 times 10. We would be delivering 600 breaths a minute. Again, if you want to blow off more CO2, you go down on hertz. If you want to blow off less CO2, you go up on hertz. Again, I'll address that very strongly in theory, and we'll draw Sally the camel humps and everything so you guys can get a good visual of it. But this is hertz. So I'm going to turn on the vent. And it's a little old school. I'm going to when you're calibrating, best thing to do is widen out your alarms. And these are just little dials. Okay. I like to center my piston. All right. This is a rookie mistake I learned fast in my career. In order to calibrate with your circuit and everything, there'll be a system calibration that will go on when it gets serviced. This is what you'll do before you put it into service with each patient. You make sure that your limit and your bias flow adjustment and your adjust are all the way up before you calibrate. Again, I'm teaching. So you'll power on. And it's a little bit violent to start out with. Center our piston. While you're calibrating, just remember it is a little bit easy to make it go out of the limit when you're centering, so make sure you just keep an eye on that. I like to start by bringing down my bias flow. To about 16, 15, 16. And you can see as I bring down my bias flow over here, my mean airway pressure changes. I'm sorry guys, this is not my best recording I've done for you. Please forgive me. I like to call this don't break the ice. So that's what it feels like. So bring this down to about 15, 16 liters over here. And after that, I'm going to adjust my green knob until we are at a mean airway pressure of about 10. 10 is normally where we start. See how my center piston's moving? Gotta keep an eye on that. It's a little stinker. Until our adjust is hopefully in about the 10 o'clock position. This is just a trick you'll learn from Allie. Once I get to about 11 or 12, I bring down my amps. So normally when it's on a patient, it doesn't totally drop your mean. But sometimes when you're adjusting it, it will. Again, learn from my mistakes. This part's really confusing. I can't wait till you guys are hands-on. Until my amplitude is 20. So a good starting place in the NICU is a mean of 10, an amplitude of 20, and a hertz of 10. So we'll adjust our bias flow just up a little bit till we're 10. And then I'll set my limit so that we have a difference, because otherwise it's going to dump and adjust that limit. So again, the limit is to help us make sure we don't have increased pressures to cause barotrauma. Okay, the last thing in order to make sure our vent is calibrated is to bring our hertz down to 10. Okay, and then just a little bit of fine tuning. One thing you'll find is sometimes the oscillator makes me feel like a super cool DJ because I'm adjusting all my knobs. There's a lot of just little itty bitty fine tuning features that you guys will find you'll have. So again, our mean airway pressure is 10, our amplitude is 20, and our hertz is 10. That is how you would, once your circuit and everything's set up, you do your device check, that is how you would calibrate the circuit to make it ready so it can go on a patient. The final thing you will do after you make your mean airway pressure 10, your amplitude 20, and your hertz of 10, I time 33, we have a difference in our limit and our adjust, and we bring our bias flow down from 20 down to about 16, is set our alarms. And you can do this about 5 to 10 above. So with 10, I'll probably put it on, oh hush, 15. And then maybe 8. Or we'll do 7. Okay, so let me show you. If I press the start stop, see how it maintains that mean airway pressure, that continuous pressure. You can kind of hear it hiss a little bit, but the oscillation stops for assessment purposes. That's what's happening. And then you just press on in order to return to oscillation. Okay guys, that is the oscillator. I hope we can get a little more hands-on time in lab. It's not as scary as it looks. Once you break it down, it's really a great piece of equipment. It's really good, especially if you have a kid with really stiff lungs, but you want to be lung protective. It's excellent for lung protective strategies, excellent for recruitment, one of my favorite pieces of equipment. I will work on getting a video for theory to help you guys out for reference purposes. And that is the high frequency oscillator. Come to class with questions and let me know if you need anything. Sorry this was a little bit of a more balky video than my ones in the past, but hopefully this helped. Thanks guys.